So I know there were steps on this one on Edgenuity already, so this is part of the instructions, but I am going to choose a different method to solve. So first I want you to look at the denominator. So I'm going to have orange, red, and yellow. So you'll notice that we will be solving for x, and right now these variables are in the denominator. In order to add fractions, so you'll see this addition here, in order to add fractions, I want my denominator to look exactly the same. So that's my goal. You'll notice here on the right in yellow, we have a quadratic. So today in class, we learned how to factor this quadratic. So we have, I'm just going to pull this one out for a moment, x squared minus 25. You might think, so this looks a little bit different than the example we did in class, but here, let me rewrite it in a different way. X squared plus 0x, because we don't have a term in the middle, minus 25. So now we want to think of two numbers. When we multiply, it equals to 25, but when we add, we want it to equal 0. So you're like, well, the good thing about 25 is it's a square number, which means there's not that many ways to get 25 besides 5 and negative 5, right? And I think the only option is 1 and 25. So it can be negative, -1, and 25. You'll notice here, 5 and negative 5, when you multiply, we get negative 25, but when we add, we get 0. So we know that if we wanted to factor this, it would be first the x's, it'd be plus 5 and minus 5. So I can rewrite what I have in the yellow highlighter with this. I'm rewriting it and by factoring. So if I were to just kind of draw a line here and rewrite the entire equation, I have x over the same x plus 5 over 5 minus x. I have equals to x squared plus 25 all over x, all over, and then we factored the x plus 5 and then the x minus 5. So now that we see it like this, if I were to just go back and highlight, you'll see that we have the x plus 5, and you'll notice that this looks a little bit different. We have 5 minus x and we have x minus 5. They're not the same, but they do look somewhat similar. So what we're going to do here is multiply both of these so that they look somewhat similar. So first, I do want to mention, here in red is x minus 5. This is 5 minus x. So here, my 5 is positive. Here it's negative. Here my x is negative. Here my x is positive. So I want this 5 minus x to look like x minus 5. So what I'm going to do here is multiply by -1. Then the positive will turn negative and the negative will turn positive. That means I also have to do it to the numerator. So now I have x over x plus 5. So now the numerator turns 5 times -1. So now it's -5. And then here I have -5 plus x. Just that. I want to reorder this so it looks the same. So I'm just going to just using commutative property, I'm going to switch these two around. So I get x minus 5. Yay, so now they're officially the same. And then once again, these are the same. So right now on the left side, we want them to have common denominators so that we can add them together. So for the equation on the, sorry, not equation, the fraction or the rational on the left, I'm going to multiply by x minus 5 so that the denominator will all be the same. This one only has x minus 5, so I'm going to include by multiplying an x plus 5. So if I do that, if I were to, so I have x times x minus 5 all over x minus 5, x plus 5, plus negative 5, x plus 5, all over x minus 5, x plus 5, is equal to x squared plus 25 all over, I'm just going to switch them so, just visually we see them all the same, x minus 5, x plus 5. You'll notice right now we spent a lot of time so that all of these have the same denominator. What we can do now is multiply the left side and the right side by x minus 5, x plus 5, so we can just wipe out the denominator. Then we get x times x minus 5. So all we have is the numerator now. X squared plus 25. Because what this did was it eliminated my denominators because they were all the same. From here, I am going to solve algebraically. So here I would use distributive property. Here, distributive property. X squared minus 5x minus 5x minus 25 is equal to x squared plus 25. So let's combine the like terms. I'm just going to combine these two. X squared minus 10x minus 25 is equal to x squared plus 25. I want to isolate x, which means I want all the x's on one side. So let's get this x squared eliminated on the right, then move it to the left. What happens then is, they actually eliminate each other. So all we have is negative 10x minus 25 is equal to 25. From here, I'm going to keep going. Add 25, add 25. Negative 10x is equal to 50. Divide by negative 10. X is equal to negative 5. So this is one of the solutions. But although we got this as a solution, we do want to note that if we go back here, I had x minus 5 and x plus 5 in the denominator. So the denominator can never equal 0 because if it equals to 0, then my whole fraction becomes undefined. So you'll notice here that if I plug negative 5 in to this equation, it would have created an undefined situation. So this would be considered an extraneous solution because if we plugged in negative 5 right here, let me just show you right there, you'll notice negative 5 plus 5 is 0, and the whole fraction shuts down and becomes undefined.